Hello IB, we're looking at 19b where we're now looking at the area between two functions. So if we've got two functions where we've got our f of x is greater than our g of x, that means the y values of this are higher than the y values of that for those particular x values. In other words, between a and b for this particular domain. So that means we've got our graph looking like this, where we've got our f function is higher than our g function between a and b. Outside it does different things. What we're trying to do is get the area between these curves. So this area here, it was what we're after. Initially we might look at that and go, well, that looks a bit complicated because it's above the curve and below the curve. So what we do is we shift everything up. We do a vertical translation, and that's where we get 0k. Remember that vector notation. We shift both functions up k amount. So whatever k is, as long as we get both of them above the curve. And then we've got in between here, our f of x plus k is our upper function, g of x plus k is our lower function. So what we can now do is our integration, and we get this area. So we can now take this area here, calculate that, and then subtract the area underneath our g function. So if we get this blue one minus the green one, we're left with this area here. Alright, so that gives us that left over, which is what we're after, and we're not worried about being above or below the axis. So how do we do that? The first thing, if we want to integrate, we've got our bottom and the top, that's the vertical side of things. Now we want to know horizontally how far we go, and we're going to need our points of intersection. So the first thing we need to do is get our points of intersection, and we can do that by equating the two functions. So find out where f of x equals g of x, solve for that. This could be with or without a calculator, and then we can do our integral. So there are boundaries between a and b. We want the area under f of x plus k, that's our upper function. That's this one up here. So this is our upper. And we want to subtract the area under our curve between a and b for g of x, which is the lower function. Alright, so let's now expand that and use our integral rules. We can separate that into two integrals. And what we find is that when we split that into here, we're going f of x dx, that integral, plus the integral of k dx, minus, inside brackets, the integral of gx dx, plus the integral of k dx. And we see that add that minus this, and they end up cancelling. So it's not like we really need to know what k is, because it cancels out. And so we're now left with just the integral from a to b of f of x minus g of x dx. And if we want to write in a different way to remind us that it's the upper minus the lower for that interval. So we don't actually need to shift them, but we can see mathematically why it works just to subtract them. It's as if we've shifted them, but we don't actually do that. So the integral of f from a to b of f of x minus g of x is the same as the upper minus the lower. This is always positive because we're shifting everything into the positive region, and therefore the area between them is positive. So yes, it is always positive. We can see that when we were doing this function, all right, and we had the area underneath a curve, it's almost as if we're going f of x is equal to 0, our upper function, minus g of x, our lower function, between a and b. The area between f of x equals 0 and the curve is 0. So we get 0 minus g of x. So we get minus from a to b of gx dx. So that would be a negative area because it's underneath the curve. So we end up with the whole thing ends up positive because we've got this negative. Where's my pen gone? We've got a negative here, and this bit in here is negative. So we end up with the net result of it all being positive. Next one here is where we're doing this graph of y equals 3x squared minus 8x plus 4. So it's a quadratic. It looks like this on your calculator on a curve. So what we want to do is get the area, and we're looking at how to do that with your graphing page on your calculator, and you could also do it on your calculator page. So let's have a look on your graphic on your calculator. This is our first function here. So y equals 3x squared minus 8x plus 4. If we're trying to find this area between the curve and the x-axis, then we can simply go to our menu, analyze graph. We want the integral. We need to know the lower bound. So we've either calculated that, or if you hover over the x-axis, it gives you that. Come across, hover over that intersection point, and there it comes up. So it's hovering over the point on the x-axis, and we'll show you where the actual x-intercepts are. So we come out with minus 1.19, which we've got on here. If you want to do it on a calculator page, then you need to solve and get the x-coordinates for the points of intersection. So you could use nsolve, but that only gives you the first root, not the next one. So you'd have to do it again and have x greater than 0.667. It gives you the one closest to the x-axis. Otherwise, Polyroots solver is a lot quicker doing that, and you come out with your two roots, and then you can do your integral with this function and putting in 2/3 to your function into there, dx, and you'll come out with that. I think you've done that before, hopefully, so we'll move on. Next one here is where we've got a linear function and a quadratic, and we want to again do this with and without your calculator. So here are our two functions. Our y equals x minus 3, and this one is our x squared minus 3x. First job is, assuming we don't have a calculator, is to find out what are our points of intersection. So equate the two functions. So we get x squared minus 3x equals x minus 3. Put them all on one side, factorize and solve. So we come out with 1 and 3 are the points of intersection, which we can see clearly from this graph, but you won't probably have it that accurate if you were sketching it in on paper 1. To get our area, because our linear is the upper function, it's above, minus the quadratic one, which is below. So we want x minus 3 subtracting our quadratic. Note the use for the brackets. You want to subtract everything, so put that in brackets to remind you everything gets subtracted. Then we need the big brackets before we write our dx. So we have our integral from 1 to 3. Expand that, get your negatives and positives correct, combine like terms. Now integrate and integrate that. Substitute it all in for 3 to 1, so 3 cubed over 3 plus 2 cubed over there. So that comes through. Careful with your numbers so that we get minus 9 plus 18 minus 9, they all cancel, minus 1/3. So again, use your brackets to group things together that need to be subtracted. We come out with 1 1/3. So that's doing it without a calculator, so that's quite doable. Let's now have a look at that with your calculator. So here are our two functions graphed, x minus 3 and our x squared minus 3x. So to calculate this area in here, go to menu, we want option 6 to analyze. In this time we want a bounded area. So we want to see the area that's bounded by two functions. And as you slide over again, it gives you that option of point of intersection. Keep going across, point on intersection point. So we choose that one. And there's our answer of 1.33. So note this is a positive area, even though it is below the x-axis. So that's an important thing to remember. If it comes out negative and you've done that one function over another function, then you've got a mistake. It will always come out positive. So the important thing to note is that point. So there's that point. The area is positive even though it is below the x-axis. So this area down here. The next one here, this is asking find the total area between the two curves contained by the f of x function and the x-axis. So if we want the total area, it's not just saying find the integral between here and here. It wants this area plus that area. So we want it, that one's already positive, but this is negative. So we want to turn that into a positive bit. So for this function, we want to find out where the function is above and below. We need the x-intercepts. So we've got x equal to 0 after you factorise, 0, 1 and minus 3. They're our three x-intercepts. So we want the area between minus 3 and 0, and because that's above the x-axis, that'll come out positive. But this area between 0 and 1, that's negative. All right, so what we want to do is take the opposite of that. We want to add the negative, so we want to go minus this, so it ends up positive. This is just doing it manually, doing your integration, and you come out with that value. So on your calculator, you could just work out those x-intercepts and then integrate it. The other way to deal with it is to get the area between two functions on this interval, and even if it's all above the x-axis, what you can do is take the absolute value of the difference of the functions. So this is like the modulus or absolute value. And if you remember, when you do that, that's going to turn everything into a positive. So instead of the function dropping down below, all right, that will come up above. So let's type that one in and have a look at it. So to type this in, remember you go to this like a catalogue button. There's our absolute value. Oops, come back. All right, so we'll try again. There, type that in, and we've got equals the absolute value of x cubed plus 2x squared plus 3, was it? Oh, minus 3x. Minus 3x. All right, let me check that to see what's happening. Okay, so I had an equals instead of a plus. So now we've got it all graphed. That's what it looks like. There's our intercepts that we found earlier. So now if we want to get our integral, our area under the curve, we can just simply go to Analyze Graph, Integral, because it's going there. We want to go from this point, intersection, right through, we want all of it, intersection point, and we come out with our 11.8 for the area under the curve. So that makes it much easier than having to take two different parts and integrate them separately. So we've got 11.8, which is round three significant figures for 11 and 5, 6. So using your absolute value on your calculator. This one here, we've got y equals e to the minus x minus 1. Remember, e to the minus x will look like this. And if we're going minus 1, we're just shifting it all down 1 unit. That's at 1. So this is coming down to 0 here. And if we want this bounded by the x-axis, this function and x equal to 2, then it means, let's say this is 2 here, this is our boundary, so we're trying to get that area. You would expect if we want the value of the area bounded, they're wanting a positive number. It's not saying what's the integral, it's saying what's the area. So in that case, if we want the area, we want area equals negative integral of lower bound is, sorry, got interrupted there. So we want our area from a negative because we want to make it positive. You should be able to work out that point of intersection here is 0 because it was at 1 and it's shifted down. So we're going from 0 to 2 of brackets e to the minus x minus 1 dx. Anyway, we'll leave you to do that one. Try and do it without a calculator and with a calculator. This one here, where we've got two sine curves, we've got sine x and sine of 2x. The question is which one is which. Sine x as our base curve we know has a period of 2 pi. So that means this one here is our sine x. And this one here by default must be sine of 2x, which you should know because the period of that is going to be 2 period equals, let me just, that got a bit messy. Period equals 2 pi divided by the b value, which is 2, which is equal to pi. So there's one period, and this one here is our y equals sine of 2x. So if your trig needs revision, now is as good a time as any. So we want to get the area between these two curves. The thing to note here is that our upper curve in this case is this function, and then our upper curve over here is this function. So when you're doing it without a calculator, you then need to do sine of 2x minus sine x for this part and sine x minus sine of 2x for that part. But obviously your first job is to find out those points of intersection. So you're going to need to solve sine x equal to sine of 2x. Hopefully that doesn't frighten you because you're finished doing all your trig. Turn your sine of 2x into 2 sine x cos x, and then go through and solve all that. Take it all on one side, factorise it, get equal to 0, and solve for x. So let's see if you can have a go at that. Get those points of intersection, and then do your integral. The other one, this was just space to do the rest of it. Anyway, so have a go at that, and hopefully you can finish working through it in class. Thanks for listening. See you later.